more. Basically what? Synchronous clear preset, as well as we have seen that where we use pre-bar, clear bar. Okay, all those things we have seen in the last class. So in today's session, we are going to see what? We are going to see basically what is the difference between synchronous and asynchronous counter first, and then we are going to start with the decoding logic of your asynchronous counter. Okay, so let us begin then. So asynchronous counter, it works on the principle of toggling operation. Always, okay, it will always work on the principle of toggling operation. And toggle, it happens in two mode only. One in JK flip flop when input is 1 for both J and K input, and in your toggle flip flop when T input is 1, at that time we have toggling operation. So in asynchronous counter, always you are going to see what? You are always going to see either JK flip flop or T flip flop. Whereas in your synchronous counter, it is based on the principle of next state equation. So you can use any flip flop for the construction of synchronous counter. Okay, synchronous counter, you can use D flip flop, T flip flop, SR flip flop, JK flip flop, whichever flip flop you have, you can use it. So am I audible properly? Screen sharing is okay, but am I audible? Okay. So asynchronous counter, I have already told you that asynchronous counter are either up counter or down counter. With the help of clear and pre, we can reset the counter at a certain state, but the counting will be always either up counting or down counting. Okay. But in synchronous counter, we have seen we can take any state of counting like 0 to 1, then to 5, then to 3, okay, and then again back to 0. So we have seen that we can achieve such a counting state in your synchronous counter. Why? Because synchronous counter, it takes help of your next state equation. Okay, so today we have is few questions we have. So okay, let us see how many questions we can solve, and then we will start with the decoding of synchronous counter. Okay, so first this question, solve this question. So very quickly. Okay, or else what we can do, all the questions let it be. So okay, one more thing I have to say, tomorrow we have one class, but that class will be only for EC and electrical. How many of you are from EC and electrical? Let me know once. EC electrical. EC. No one else? Okay, fine. So tomorrow we will have class. So that will be ADC DAC. So only for ECE only. So only Shruti will be attending. Okay. So that is okay. So what I will do, I will give all these questions as homework. Okay. I will send it to you, this PDF after the class. You can solve all the questions, and then in the next to next class, when we have this session, so at that time we will do what? We will solve all the questions first. Okay. So, okay. Now let us see what decoding logic of asynchronous counter. Okay, decoding logic of asynchronous counter. So you can see what, that this is your asynchronous counter. Tell me one thing, is this up counter or down counter? Up counter or down counter? Come on, we can be very quick in this. I have told you the trick. See, you are giving negative edge triggered, and the clock pulses are taken from the non-complemented output. So different means this is up counter. Very quickly you can say what? Means are you guys revising or not? Tell me the problem. What is the problem? Let me know, because if you guys don't say, this is the starting of your preparation, and you think, if you are thinking that everything we will be able to do, that is not the case. If you are studying, you should study properly. So where is the problem? Why can't we answer it very quickly that, sir, this is up counter? And you should have told me. I have already told you the trick that look over here, this is negative edge triggered. So negative edge will correspond to minus sign, and your clock pulses are basically given from your non-complemented output. You can see at each of the state. So non-complement corresponds to plus. So whenever there is sign difference, so at that time we have up. Whenever same sign, we have down counter. So haven't I told you guys this trick? So this trick I have already told you. So where is the problem? I want to know. Okay. So let me give you one question to solve. Let's see how many of you are able to solve. Solve this question. And your answer should be given in like 1 second. 5 seconds. Okay. Worst case was. What happened? Means this question should be like solved within 5 seconds. D we are telling. What about others? So it is given in the question, in the modulo 6 ripple counter shown in the below figure, the output of the 2 input gate is used to clear the JK flip flop. So this 2 input gate is used to clear the JK flip flop. The 2 input gate is. So if you look over here, you don't even need required to determine whether this is up counter or down counter, because you can see there is clear input present. So clear input means up counting. Why up counting? Because we will be clearing the state whenever this clear input is high or low, depending whether this is active low or active high. So we will be clearing the states of flip flop. So when we clear the states of flip flop, when it is up counter, we clear it from 1 to 0. Okay, fine. So this is up counter. Now look over here whether this is active low clear or active high clear. This is active low or active high. This is active low clear. Active low clear. Why? Because there is bubble present over here, and I have told you that active low we can either represent it like this, means sorry, I am making a clock over here, clock pulse. So active low, either it can be represented like this, clear or clear bar, or it can be represented like clear bar, or it can be even represented like this along with clear bar. So whichever way it is written, this implies active low clear. For normal clear, it should be written like this, clear. So these are all flip flops, okay? Flip flop. So I went wrong. Yes, this is active low. And if this is active low, we know what? For active low clear, we have to convert the ones to 0. So we search for 1 in your what? In your up counter. So we have to convert the 1 to 0 for this clear to be getting activated. And when is this going to be 0? See, if over here this is NAND gate, so this is modulo 6. So modulo 6 up counter means what? 110. This state shouldn't be counted when you are coming from 000 to 101. So the moment you get the state, this should go back over here. The counting state should go back to 0, 0, 0. So for the first time, you can see this 2 input, it is 1 over here. Okay. So that means what? If we use a NAND gate, then we will get 0. If we use NOR gate, what will happen? We will get 0 over here also, but NOR gate, even over here we will get 0. Why? Because 1 plus 0, this is equal to 0. So over here also we will have what? We will have 0. So that means NOR gate cannot be used, and I have already discussed no need for even checking the option. I have already discussed with clear bar, either we use NAND gate. So NAND gate is used when it is active low, and AND gate is used when it is active high clear. In the last class only we have done. So option A is correct. You can see in the last class only I have discussed this. So where is that? You can see active low NAND we are using, active high and we are using pre. In pre, for active high we are using NOR, and for your pre bar we are using simple OR. Okay, so all these things should be known to you now. Is this clear? Raju, you have some doubt? So we have done this or not? Yeah, it's okay. I know you have considered it active high, so it's okay. No issues. Okay, so where was the question? We have finished this question. Okay, tell me this question. See, they only make the question little bit complex for you guys to see. Okay. First, tell me whether this is synchronous counter or asynchronous. Second, if it is asynchronous, what is the counting state? Means whether it is up counting or down counting. Okay. Third, okay, third will be your answer. Okay, so tell me the answer. So you are telling asynchronous, good. So if it is asynchronous, either it will be up counting or down counting. So, okay, tell me one more thing. Down. Okay, you are telling me down. Okay. How will your counting look? Whether it will be Q4, Q3, Q2, Q1, Q0, or Q0, Q1, Q2, Q3, Q4. A or B? A. Okay, fine, very good. So look over here. The 5 JK flip-flop are cascaded. Okay, so you haven't given me the final answer. So give me the final answer and then I will explain. See, questions are very simple. Only thing is that you should have understood the concepts properly. If you have understood the concept properly, you will be able to solve all the questions, or else it will look very difficult. So what is the answer? 250 kilohertz. So always remember to check whether the answer is asked in kilo or mega. Okay. So I have once made a mistake in 2020 when I had appeared for gate in this only. Okay. So 2 marks were lost. So look, first question I asked you is what? Whether it is synchronous or asynchronous. So you can see clock pulse is being given to the first flip flop, and after that, what is happening? The output of the first flip flop is serving as the clock for the second. For the third flip flop, output of the second flip flop is serving as the clock, and this is going on. So first is what? This is asynchronous. If this is asynchronous, it needs to be either up or it needs to be down counter. So you can see over here that the clock is what? It is positive edge triggered. Along with that, your output is taken from where? It is taken from non-complemented part. So that is plus. Same sign, that means down counter. So over here we will be counting down, down counter. And you can see over here that basically we have 1, 2, 3, 4, 5 flip flops. So that means it will be counting from 31 to 0. So this is what? This is mod 32 down counter. Okay, mod 32 down counter. Fine. So next I had asked you whether this will be the counting sequence or this. So I have told you the flip flop that is farthest from the external clock, that will be your MSB. So this will be MSB, this will be LSB. So that means which option? Option A is correct. Now we need to find what? 5 JK flip flop are cascaded to form the circuit shown in the figure. The clock pulse at the frequency of 1 megahertz are applied as shown. The frequency in kilohertz of the waveform at Q3. So we need to find the output frequency over here. So we know the frequency over here, it will be f clock by 2, means at over here it will be f clock by 2 to the power 2. Over here it will be f clock by 2 to the power 3. Okay, over here, so this is what is asked, f clock by 2 to the power 4, and at the last place over here it will be f clock to the power 2 to the power 5. Now you can find f clock is given, it is 1 megahertz. So they are asking in kilohertz. So f clock is what? 1000 kilohertz divided by what? 2 to the power 4 over here. Okay. Sorry, I have done some mistake. Oh no, it's okay. So this will be what? F clock by 2, F clock by 4, F clock by 8, F clock by 16. So this will be 500 by 8 or 250 by 4, or this is 125 by 2, or this will be what? 62.5. Yeah, so 62. Why are we getting 250 kilohertz? What mod 5? What is mod 5? And why are you getting 250 kilohertz? So 250 kilohertz we will get over here. So this is wrong. 62.5 kilohertz is the correct answer we will be getting at Q3. So Q3 f clock by 2 to the power 4. Did we understand or not? See, I am getting to know that you people are not studying. Okay. See, I will not be telling that I am the best teacher, I have delivered everything. But whatever I have actually told you, I am using that concept only. Okay. So still if you guys cannot do, if you cannot solve question, so tell me where I am, means where I am at fault. Okay, and this is not good. This is not good. Not good at all. That's such easy question. This is a 1 mark question. You are not able to solve. Is frequency of Q naught not same as that of clock frequency? What Q naught? Why it will be same as clock frequency? What is happening here? What is happening with you? This shows that you guys are not at all you guys are doing what? You guys are not at all revising. So look over here. Over here, this is your Q naught in the last question. So if over here I was applying F clock, you can see what? Here your time period is getting what? It is getting twice. So over here, this is F clock by 2. And what is this? This is QA. So QA means at this point it is F clock by 2. Over here it is F clock by 4. And over here this is F clock by 8. Already I have explained all these things. You can see over here. In each of the places I have explained. No. This is very, very sad thing, okay? That still you guys are having such kind of doubt. So this is very, very bad. Means I cannot even scold you. So still I have explained all the things, and such kind of doubt, if it is creeping up with you guys, then it is very pathetic now. Means all these things I have explained. You cannot say, sir, you haven't told us this and now you are asking us. So I have given whatever I know, and if you are telling me, sir, that output over here will be same as clock, you tell me how can I digest that fact? You can see everything has been explained over here. So how can you guys even tell me that, sir, we don't know, we are not getting this? So if there is something new concept, then let me know. How many of you got 62.5 as your correct answer? Tell me. How many got? Anyone? Anyone you got the correct answer 62.5? So where is that question? Yeah. Anyone? Chandana? Raju? Shruti? No one. So this basically shows that out of you 4 guys, nobody is actually revising, or nobody is just worried about your future. So I am coming, I am teaching you guys. Simply you guys are sitting for like 2.5 hours and you are doing nothing after that. Tell me. Okay, last now, last, okay? Okay, solve this question. Quickly, solve this question. So what answer are we getting? See, answers, it's more than 1 minute. So these are all means like 1 minute questions if we have understood the concept. So now I know in the class there are only 4 students present. So I take means care that each and every one of you understand, and after that also if you are not able to give me any answers, then how is it possible? Answer, anyone? Any option? Mod 4. Okay, let us check. So what is given? The figure shows a binary counter with synchronous clear input with encoding logic shown. The counter works as. What is this counter? So you can see over here that this is clear bar. So clear bar means this is your up counter, and clear bar. So that means what? This is what? This is your XNOR gate. What? XNOR gate. So XNOR gate is 0 when both the inputs are what? Both the inputs are different. So Q3, Q2, Q1, Q0. Okay, so we have this. So counting sequence will be, so let us assume this is Y. So if this is 0, 0, 0, 0, Y will be 1. Next will be 0, 0, 0, 1, Y will be again 1. Next will be 0, 0, 1, 0, Y will be again 1, because Y is what? Q3 XNOR Q2. Okay. So now next is what? Next counting state is 0, 0, 1, 1. So again you can see this will be 1. Now in the next case, this will become 0, 1, 0, 0. Now at this time, whenever we have different states, input states in your XNOR, output will be what? It will be 0. Now the moment this is 0, what will happen? Clear will be getting activated, and all this Q3, Q2, Q1 will again go back to 0. So the next state will be what? It will be 0, 0, 0, 0. So now we have to see what? We can see basically what? That this is 1, 2, 3, 4. So this is what? This is mod 4 up counter. So option B. And I guess Shruti and Raju have said mod 4. So good. Okay. Mod 4 means I shouldn't be telling good. So one thing actually we skipped over here, that is what? That this is synchronous clear input. And if you have missed this, you have marked mod 4. I have told if it is synchronous counter, then actually the counting state is basically whatever we get in your asynchronous counter plus 1, or wherever we are switching the states, that will be also your valid state. That means this will be the counting states of your synchronous clear input. If this was your counter using asynchronous clear or clear bar, then it would have been mod 4. But using synchronous clear or clear bar, this will be what? This will be mod 5 up counter. This will be mod 5 up counter. So the correct answer is option C. Option B is wrong. So only one person has solved this question. So this is the condition of your class. Now tell me, with this concept, with all this much, if I explain you guys today this thing, what? Asynchronous counter, how are you going to means this is one of the most conceptual topic that we have, and half of you are having confusion whether it is up counter or down counter. So this even shows that you guys are not even solving questions, because if you had solved questions, then if you had doubt, you would have asked me, sir, we are getting problem in this, please you tell us what we will do in this. So none of you said me. This is not how we are going to proceed. I am telling you this. This is not how we are going to proceed. So I will pause. Let me ask. See, they have asked you, there is one sequential circuit. Okay, what it does, basically it counts the inputs, number of zeros and number of ones. Okay, it counts your inputs, number of zeros and number of ones in a k bit input. So zk is number of zeros and nk implies number of ones. Okay, number of ones in your what, in your input bit. So total input bit is what, it is a k bit input. So they have told you basically zk plus nk is equal to k. So that is what will be there. The circuit output 0 0 until one of the following condition is hold. So the circuit will be 0 0. Okay, this output will be 0 0 until any one of the following conditions hold. If one of the following condition holds, okay, holds true, one of the condition is what? First is zk is equal to nk plus 2. So if this happens, what will happen? Your output will jump from 0 0 to 1 0. Next condition is what? If your nk is equal to zk plus 2, then once again what will happen? Your output will jump from 0 0 to 1 0. So this they are asking. So this they are asking now, what is the minimum number of states required in the state transition graph to represent this circuit? Okay, so how can you represent? Yes, tell me.
Is it 0 0 to 0 1 for the second condition?
Yeah, 0 1. Okay, 0 1. So now they are asking, when means how many, you can see only these two conditions. For these two conditions there will be transition. So first tell me how many zeros, means what can be the condition or what can be the number of sorry, let me ask you once again, what can be the all the possible cases over here? Okay, possible cases. So those possible cases you can get from this two equation. Look over here, zk minus nk is equal to 2, and the next is what, if I take this equation 2, so zk, sorry, this will be zk minus nk, or zk minus nk is equal to minus 2. So you can see zk minus nk, it can vary from 2 to minus 2. So these two conditions are given, that your zk minus nk can vary from plus 2 to minus 2. Now this is actually specifying what? This is actually specifying this inputs only. Input, the condition on the inputs. So now your difference in the input bit in the number of zeros and 1, it can be either plus 2, or it can be what? It can be plus 1, or it can be 0, or it can be minus 1, or it can be what? It can be minus 2. So if this is the case, look how it can be. So it can be like this, zk is number of zeros. So zeros can be like, your input bit can be like 0 0 0 0 1 1. So over here if you see zk is 4 and nk is what? 2. So zk minus nk is what? It can be 2, or it can be like 1 1 0 0 0. Your input bit can be like this also. So at that time you will be having plus 2. plus 1 when you will have. So either if you put a 1 over here, so this will be 0, sorry, this will become 0, this will become 0. So here I need to do what? I need to add 1 over here. Okay, so then it will be 4 minus 3, yes. And over here also, if I add 1 over here or at this place, I will be getting the difference between the number of zeros and 1 as plus 1. So over here you can see two things are getting decided. One is the number of bits. You can see whenever we will be getting even number, when do we get even number? When we subtract two even number, at that time only we will get even number. And when do we get odd number? We get odd number when we subtract an even number from odd number or odd from even. So even number we will always get from subtracting two even number, even minus E2 or E2 minus even. Okay, and your odd number you will get when you subtract, okay, even when you subtract two odd numbers also you will be getting even number, like 5 minus 3 if you do, or 7 minus 3, you will always get even number. But for odd number to get, your either subtraction should be between even and odd or odd even. So when you add one even odd, so basically this number of bits, this E or O, these are basically ZK and NK. So K will be when you add even number and odd number, you will be getting odd number. And when you add two odd number or two even number, you will be getting always even number. So this is basically deciding even the number of bits, and the difference in bit also is decided by this two equation. So you can see basically ZK minus NK can range from 2 to minus 1, 2 to minus 2. So now for basically decide what I should be saying means, for representing this 5 states, I require what? I require basically number of 5, means 5 unique state. I need to either encode it like, already these two states have been taken. Which two states? This state and this state. These two states have been encoded as 10 and 01. Now either I can encode this by 00, this by 01, and this by 010. Okay, so I can encode it like this, or even I can encode it by 01 only. No, 01 I cannot do, sorry. Already 10 means there is one more doubt over here.
Hello.
Yes, tell me.
Can we represent it by using 1 1?
So already, why am I representing 0 as 01? 01 has already been taken. So this is 1 1. So that means they have actually taken the concept of dummy variable over here. Just give me a minute. I will make you understand one more concept. Okay. So this is what? This is mod 7 up counter. Okay, fine. So can you design such kind of counting state? Like this? Can you make one counter like this, which has count states like this? Or even counting state like this? Okay, let me ask you, are these two same zeros or are they unique? So basically this is the count state. Yes, this is unique. This is unique zeros. Or else if this was not unique zeros, I wouldn't have taken them. So look over here very carefully. I have actually constructed this count state using this counter. So basically when I am counting this state, I am just taking this two as my output. QC and QB, these two are my output and this is my dummy variable. Okay, dummy variable, this is dummy variable. So if you see, so over here if you take, so this is 0, if you take just QC QB, this is 0, even this is 0, this is 1, this is 1, this is 2, this is 2, this is 3, this is 3. So actually I am constructing it with mod 7, but here you can see that I am counting only what? I am counting just uniquely four numbers, 0, 1, 2, 3, but each of the zeros are unique. These two ones are also unique, these two twos are also unique, these two threes are also unique. In this count sequence, I have basically taken QC and QA as my output and QB is dummy variable. So same concept is taken over here also, I guess, that this will be what? If this is 1 0, this is 0 1. So out of this two, okay, 0 0 and 1 1, this state can be either 0 0 or 1 1. Never take this two state because this two are what? This two are your conditional state. You can see. So don't take this two. Either you can take this one or this one. Now if I ask you how many flip-flops are going to be required for constructing this, so what are you going to say? See over here you have 5 states, 5 unique state. So that means 3 flip-flop. Minimum 3 flip-flop is required. So this was one of the best question I have seen till now. So basically I guess this is from computer science because I haven't seen such question anywhere in my BTech also or in my MTech or any time I haven't seen such kind of question. Okay, so this was one very good question. Very good question, I will say. So I am very sure if this question is asked to ECE guys, 100% of the students, if one or two, except one or two, so I will not say 100, 99% student will not be able to solve this question because such kind of question we haven't seen. Okay, so this was very good question.